Yes, found out Friday night at 6 o'clock. So I'd like to acknowledge my co-authors on this particular chapter, in particular Adam Cottrell, who couldn't obtain the travel approval to come. Adam was the lead author on this State of the Lake chapter and compiled a lot of the data that you're going to see today. To kick things off, I wanted to show this historical perspective. This is showing lake-wide Carighanine yield in Lake Huron, just showing the trends through time. And that dotted red line is the current fish community objective that we heard about earlier from Chris. The focus of this talk is lake whitefish. So obviously what we can see is that since really the 70s, lake whitefish have been the dominant harvested Carighanine in the lake. And in terms of the current reporting period, we see that the current yield for lake whitefish is falling quite a bit below that fish community objective, and that yield has been trending downwards during this time period. Another thing to point out here is that these low levels are not unprecedented. We have seen them at time periods in the past, and the population increased or decreased thereafter. And that is also, you can also sort of see that when we look more specifically at the lake whitefish harvest within Lake Huron for these different regions. Again, we can see that although during this current reporting period we're at fairly low levels, we have seen those low levels back in the 1980s. So here we're looking at yield for the different locations. So on the bottom in green we have Georgian Bay in Ontario. In the black we have the North Channel. The main basin in Ontario makes up the highest proportion of the catch. And then we have Cora and Black and Michigan at the top. And so we see this overall decline. And then we also see that for most locations, the bars are getting smaller, showing that we're seeing these declines in many spots. However, you see that the extent of the decline isn't the same in all areas. Now, some of that decline in yield is coming about through a decline in effort in recent years. So this is showing gillnet effort, that's the red, and trap net effort. So this is an estimate of total lake-wide effort. And so during the most recent time period, we see this declining effort trend. So that's going to contribute to those lower yields that we're seeing. And of particular point here is that we see that the current effort levels, most recently estimated, are the lowest that we have seen. So although these trends in effort are going to contribute to the lower yield, all indications are that the population abundance in biomass is also declining, and that's contributing to the declining yield. So this is showing an estimate of lake-wide biomass from the statistical catch-at-age models that have been developed for different locations. You don't have to focus too much on the different colors here, but I just wanted to make the case that our estimates are that the lake-wide biomass is also declining. And again, just as we saw for yield, there's been a different amount of decline in different locations. So those estimates, of course, are from the statistical catch-at-age models, which are relying on commercial data. But we're also seeing indications of declines in relative abundance from our fishery independent monitoring programs. So this is showing trends in the mean catch per unit effort, that's the blue lines, and in the mean age over time as measured in multi-mesh gill netting surveys conducted in different locations. So the most obvious trend that we see here, so we're looking at northern Main Basin in Michigan, southern Georgian Bay in Ontario, the southern Main Basin in Ontario, and the central Main Basin in Ontario. And so what we see is that across the board, pretty typically, we're seeing this decline in the mean catch per unit effort over time. And at the same time that is occurring in all but one spot, we actually see this increase in the mean age, so those red dots. And what this is indicating is as that relative abundance is dropping, our population is aging, and this is because we're seeing less recruitment coming into the population. Now you'll note that in the southern main basin, however, we don't see this trend in mean age. So the mean age has remained relatively stable. So there are some differences in different spots. This information is probably not new to many people. So for quite some time, there's been indications that there's been declines in growth and condition of lake whitefish. This is showing data from the Ontario waters of Lake Huron. So we're looking at trends in the mean length at age 4, that's the blue, and in the condition factor, that's the red, for these different locations in Ontario. And so what we see is that generally over time, the long-term trend was this decline in growth. However, you will note that in the recent reporting period and most recent years in several locations, we're seeing that the mean length is increasing again, and in some cases has returned back to its earlier levels. Now, one of the reasons for these recent increases in growth could be that we see that lake whitefish are switching to consuming more round gobies. So after dreissenids came into the system and we saw the loss of diapria, a lot of lake whitefish were actually feeding on dreissenid mussels, but now in more recent years they're feeding on round goby, so this is going to offer a richer source of energy. As well, because abundance levels in our population are so low, this could be contributing to some release of density dependence. Now, it's important to note that these changes in growth have been observed elsewhere in the Great Lakes, so it's not just happening in Lake Huron. So this was a study where we took archived scale samples from agencies around the Great Lakes and did back calculations to measure early growth rates. And what we found was that consistently in locations where dreissenid mussels have become established and where we've seen these declines or loss of diapria, growth rates also declined. Where we didn't see these changes was in Lake Superior, where dreissenids, of course, haven't become established in large numbers. Now, earlier on in the time series, when you look at trends in growth over time, some of the declines in growth could be attributed to density dependence, so as the population biomass was increasing. So here we're looking at the relationship between mean length at age 4 and the total population biomass for the southern main basin of Lake Huron. And so what we see is that earlier on in the time series, and you can follow sort of the line along, before dreissenids were in the system, and then for a few years thereafter, we see this characteristic decline in growth as the population biomass was increasing. So a typical density dependent growth response. But shortly after that time, we see this relationship pretty much breaks down altogether, and the mean length has changed, and now it's sort of moving around independently of changes in biomass. So there's been a complete change in the growth potential of this population. So these changes in growth have also coincided with quite substantial changes in the feeding ecology of these populations. So this is from those same scale samples. We looked at stable isotope trends, and we saw pretty stark changes and shifts in carbon-13 and nitrogen-15. And the direction of these changes was again consistent where dreissenid mussels have become established, and showed some evidence that lake whitefish were having an increased reliance on nearshore benthic resources than previously. And at the same time, we also saw quite a few changes in the depth distribution of lake whitefish. So the ecology of these fish is really changing. All right, so back to Lake Huron. Along with all these other changes that we saw, the most worrying trend perhaps are the declines in recruitment. So this is showing predictions, again, from the statistical catch at age models, and we're showing recruitment or numbers of fish at age 4 for these different locations where we developed the models. And the pattern that you see here is that we see this general decline from the peak that was occurring in the 1990s and 2000s. But you can see that there's some differences across the different locations. So we have Michigan, Northern Main Basin, and Central Main Basin here. We have, and then the Ontario waters shown here. So the first thing I want to point your attention to is that in some spots, like the Northern Main Basin and the Central Main Basin in Ontario, we're seeing really low levels of recruitment currently. And the shift is quite pronounced. You will note that in Michigan, in the northern Main Basin and the central Main Basin, in recent years there's some evidence of a bit of an uptick in recruitment again. But when speaking with Steve Leonard, anything past about 2010, the red line that I'm showing here, is more uncertain, just because the models are more uncertain and not as robust in these more recent years. But there is some suggestion that perhaps we're starting to see some more juveniles in some of the nets. So this could be something, but we really need more time in order to look into that and know how real this trend is. So that showed the predicted numbers of recruits, but of course the number of recruits could be declining just because we have less spawning fish out there. And so here we're looking at the number of recruits produced per unit of spawning stock biomass for different locations within Ontario. And the general pattern that we see is that there was sort of a lower level at some point, there was then an increase and a peak, and then a subsequent decline. And then we see some differences, of course, in different areas. But one of the more obvious trends is that in the northern Main Basin and the central Main Basin, again, the decline is quite precipitous, and then recruitment productivity is sitting at really, really low levels, and these levels seem to be sort of pretty much flatlining at or near zero. In Ontario, we have a pre-recruit index. This is a relative index of abundance for ages 1, 2, and 3, captured from our fishery independent gillnet surveys. And the dotted line that you see here is the mean across these surveys of 10. And so what you can see here is that, again, we see declines in this index for these different locations from the peak for cohorts in the 90s and 2000s. You'll note that in southern Georgian Bay, there hasn't been a lot of change over the past 10 to 20 years, but recruitment is sitting well below that average and at extremely low levels. Now, in the southern Main Basin, what's interesting is you'll see that although we're sitting below that mean average and this pre-recruit index is quite low currently, it's not completely different than what we saw in the early 1990s. So there are some differences. However, what this is telling us is that when we compare this to the predictions from our statistical catch at age model for age 4 recruits, that some of those declines we're also seeing in this fishery independent survey of younger recruits. So there's some indication that those predictions for age 4 also are matching up with what we're seeing from these fishery independent surveys for earlier age classes. So some of the work in my lab has looked at how have these declines in growth and recruitment potential affected the harvest sustainability of the population. And this is work that has been done by a graduate student of mine, Jenny Lee Gobin. She developed a model for Lake Whitefish in the southern Main Basin of Lake Huron on the Ontario side. And this is because this is where we had sort of most data and sort of a more robust time series. And what Jenny Lee looked at was what happens if we alter and we reduce the growth capacity of the population, shown here, and the recruitment potential of the population, similar to what we've seen in the lake after Dreissenid mussels have invaded. And so these declines are consistent with a reduced carrying capacity resulting from this regime shift that we're seeing. So basically, Jenny Lee contrasted these baseline pre-Dreissenid conditions for growth and recruitment with the current conditions, and looked at how that affected how much yield could be extracted from the population. So this is what she found. So this shows the decline in yield as you change the peak harvest rate, and that decline is measured relative to the pre-ecosystem change conditions. And so what you see here is that there's this decline in yield as you increase the harvest rate. Now this is before you put in any changes in recruitment potential. So this is just through reductions in growth alone. Now when we add the recruitment potential reductions, what you see here is that once again, yield declines as harvest increases, but after harvest rates of about 50%, harvest is no longer sustainable and the population actually collapses. And so what this is showing is that harvest levels that we could achieve in the past are no longer sustainable given the current conditions for growth and recruitment that we're seeing. All right, so to date, a lot of our monitoring and research efforts have really focused on the juvenile and adult stages of lake whitefish. And this has led to somewhat of a knowledge gap in terms of what's going on at earlier life stages. And we really need to fill that knowledge gap if we're to understand what's causing the declines in recruitment and what the mechanisms are that are involved. And so what we're seeing is a shift in research and monitoring efforts towards these earlier life stages, in particular the larval life stage, as well as just sort of over the course of the first few months of life. And there's a number of different questions that are being asked this work, one of which is at which stage are we seeing this, what's been called this recruitment bottleneck occurring. So, we see the predictions for age 4 recruitment declining, and we see some indications that earlier ages we see less recruitment, so ages 3 to even 1, but we don't know a lot of what's going on before that. So is there a survival issue that's occurring at the egg stage? Is it at the larval stage when fish are hatching? Is it over the first few months of life? Is it something happening over the winter period? We really don't know. And so that's one of the questions that's being addressed with a lot of the current efforts that are underway by different folks. Another question that's being addressed, and this is work done in my own lab, and many others are working on this as well, is getting more at the mechanism and looking at is the reduced offshore productivity and some of the changes that we heard about yesterday in Lars's talk, is that contributing to lower food availability when these young fish are hatching? So, we see declines in the spring plankton bloom, changes in zooplankton productivity and some key species. We're looking at how this is influencing growth and survival. So just very briefly about some of that work that's going on. So in 2017, we did some surveys in the North Channel off Blind River and in the fishing islands in the Central Main Basin. And then we conducted that work again in 2018 in the fishing islands. And what we did was we went out and did surface tows for larval fish and coincided those with some plankton sampling. And we went out every week from ice out for about a 6-week period until you see the larval numbers starting to decline. And so what this is going to allow us to do is to look at the relationship between larval fish density, growth rates, and food availability in terms of what plankton is out there. And we also followed this work up with some beach seining. And just a little bit of a tidbit of information that we're seeing so far from comparing 2017 versus 2018 is we did see a large increase in lake whitefish between 2017 and 2018. So we're already seeing some indications of quite a bit of annual variability. Similar work is also being carried out by the U.S. Fish and Wildlife Service in Thunder Bay. So this is work being carried out by Chris Olds and colleagues, where they have a number of different sampling locations within Thunder Bay, and they're going out and sampling, I think, at least 3 times in the spring or early summer. Again, this involves doing surface larval fish tows, in this case with a Houston net. And many folks are familiar with the beach seining efforts that are underway. So there's a sampling protocol that was designed and led by Kevin Donner, and he's also collecting all of the information. So these agencies are using the same protocol across various locations. They're going out in the early summer months, so anywhere from May through to July, and they're going to some of these beach locations where folks tend to see lake whitefish at this time period. And they're seining. And so this is going to allow some spatial comparison, so looking at different locations across the sites where the sampling is done. These are the sites that were done in 2017, for example. And then we can also compare across years as more years are sampled. And this could potentially provide a type of index for early recruitment at, again, this life stage where we really don't have a lot of information and where our monitoring nets don't capture fish. All right, so to conclude, we do have serious concerns about the status of lake whitefish in Lake Huron. So of course, we're seeing declines in yield, there are declines in effort as well, and we're seeing declines in population abundance, biomass, and recruitment. And for us working in M&R, this graph just tells a big story. So at the beginning of this time series, so this is data from our fishery independent gill netting survey that's been conducted in Georgian Bay. At the beginning of this time series, on average, you were catching maybe upwards of 10, 15, 20 fish per 300-meter net. To now, basically, we're catching nothing. The nets are empty. And most recently in 2018, I believe there was actually 0 fish captured. So this is a huge difference, and this is something that's happened in people's lifetimes. Our biologists have experienced this, or some of our technicians. It's just such a substantial change. And so these changes are being accompanied by just a broader change in the ecology of lake whitefish in terms of its feeding behavior, where they're feeding, where they're getting their energy from. And based on the modeling work that's being done, the harvest levels, given all these changes, the harvest levels that we experienced in the 1990s and early 2000s, they really can't be achieved given the current ecosystem conditions and this regime shift that we're seeing in the lake. Now, what's important to note is that the declines and the different trends are not the same in all regions of Lake Huron, and I think we have a lot more to learn by looking into that more closely. So you could see from the graphs that I showed you. And I think we have the opportunity to start piecing together the puzzle a little bit more. So, for example, the 2017 CSMI work that Beau Bonnell is working up, I think shows some indications that there's some different things going on. So up in the North Channel, there's not as many quagga mussels, and from what Lars was showing yesterday, it looks like there's even some pockets of diapria up there that are sort of increasing a little bit. And so I think there's a chance to start piecing together the puzzle a little bit more and maybe relating this to some of the trends that we're seeing in our fish recruitment and other indices. So I think we can look more into that. Finally, there is considerable research effort underway to look at the early life history stages, one of the gaps in our current understanding, because I really think we need to look at that if we're going to understand the mechanisms that are involved with these recruitment declines. And with that, I'll end.